Before you buy bigger models, ask a better question. Are you giving the model the right information at the right time and in the right amount? In this module, we'll treat prompts, context, retrieval, and memory as levers for both cost and quality. So far, we've built the FinOps foundation, how AI workloads create cost, how quality is measured, and how observability, allocation, dashboards, and routing make usage manageable. Now we narrow the focus. Instead of only choosing the right model, we'll shape the request itself, so each call delivers more value with less waste. The key idea is simple. Token waste is rarely just a pricing issue. It is usually a design signal. Vague prompts, bloated context, weak retrieval, and unmanaged memory all push the model towards slower, costlier, less reliable answers. Optimization improves the system, not just the bill. Token waste usually hides in 4 places. Prompt bloat comes from over-instruction, repeated policies, long formatting rules, and examples the model no longer needs. Context bloat happens when we pass whole documents, stale records, or too much conversation history instead of the smallest relevant slice. Retrieval bloat appears when search returns many chunks, but only a few are useful, often because filters, chunking, or re-ranking are weak. Agent bloat happens during execution, when the system loops, repeats tool calls, or resends the same context. Diagnose the source first, then optimize. Prompt compression is not about making prompts vague. It is about removing waste while keeping the controls that matter. Start by turning long prose into labeled instructions: task, constraints, context, and output. Delete repeated rules, especially when they can live in a governed template or system policy. Keep examples only when they prevent real ambiguity. And when formatting matters, use a tight output schema instead of paragraphs of explanation. A strong compressed prompt is shorter, but still clear about what to do, what to avoid, and how success will be judged. Prompt templates should be managed like production configuration, not copied and pasted as loose text. Standardize them around the job they perform, the risk they carry, the model they target, and the business domain they serve. Dynamic variables should handle user input and data, while stable policy instructions stay centrally controlled. Each template needs an owner, version history, approval path, and rollback plan. Then connect changes to evaluation scores, cost trends, and incidents. That turns prompt management into an auditable operating process instead of tribal knowledge. Any prompt change should be tested before it ships. Use a representative evaluation set that includes normal tasks, edge cases, adversarial inputs, and past failures you do not want to repeat. Run each prompt version under fixed model settings, so the comparison is controlled. Then measure more than whether the output looks good. Track success rate, groundedness, format compliance, refusal accuracy, latency, token use, and cost per successful task. The best prompt improves the scorecard without creating new risk, and should only be promoted when it clears explicit pass-fail gates. A context budget treats the model's input window as scarce space. Protect the non-negotiables first: system instructions, the user's actual intent, and enough room for the answer. Then decide how much evidence the task deserves. A simple factual question may need only a few passages. A high-stakes synthesis may need more. Memory and tool outputs can help, but they should not crowd out the most relevant evidence. Track when truncation happens, and watch whether extra tokens actually improve quality. If they do not, shrink that section. In retrieval systems, more context is not automatically better. High recall may find the right evidence, but if it also brings in noisy chunks, cost increases, and the model may focus on irrelevant material. Precision comes from tightening the pipeline. Rewrite the query, retrieve candidates, apply metadata filters, re-rank by relevance, and select only evidence that is fresh, trusted, relevant, and diverse. Measure each layer with precision at K, recall at K, and MRR, but also check grounded answer quality. The goal is not to retrieve the most documents, it is to retrieve the right few. Retrieval quality often improves before the model ever sees the prompt. Start by chunking content around meaning, a policy section, a procedure step, or a code function. If chunks are too large, retrieval becomes vague. If they are too small, the model loses context. Use metadata to narrow the search by tenant, product, region, date, sensitivity, and access level. Then rank by freshness and authority, so approved, current, trusted sources win. The result is fewer tokens, less noise, and answers grounded in the right documents. After broad retrieval, do not hand every candidate chunk to the model. First, filter for eligibility, permissions, freshness, and trusted sources. Then re-rank the strongest candidates by more than similarity. Ask which chunks match the user's intent, contain answer-ready evidence, and add distinct value. If confidence is high and coverage is sufficient, shrink the final top K. A smaller, stronger context set usually improves grounding and reduces distraction. Finally, judge re-ranking by the answers it enables, not just by retrieval scores. The best evidence is evidence that helps produce correct responses. Retrieval gives you raw material. Context assembly turns it into usable evidence. The goal is to reduce ambiguity before the model answers. Organize chunks in the way the task thinks, by source for attribution, by timeline for events, by topic for synthesis, or by decision relevance for recommendations. Keep labels, timestamps, document IDs, and confidence signals close to the evidence. Remove duplicates unless comparison matters. Flag conflicts instead of hiding them. Then give clear rules for how evidence should be used and cited. A well-assembled context packet makes grounded answers much easier. Memory is powerful, but unmanaged memory becomes a liability. Treat each store as a separate source with a clear purpose. Session context for the current conversation, user memory for durable preferences, task state for what the agent is actively trying to accomplish, and audit history for traceability. Before anything reaches the model, compress older turns into task-relevant summaries. Then remove stale, irrelevant, or uncertain facts. Enforce access rules by user, tenant, role, task, and sensitivity. The goal is a smaller prompt, better reasoning, and less privacy risk. Context optimization is also a governance discipline. The safest context is the context you never send, so minimize sensitive data in prompts, retrieval results, tool outputs, and memory. Apply policy checks before context is assembled, not just after the model responds. That means redaction, role-based access, and relevance filters happen upstream. For auditability, keep metadata such as user, source, policy decision, and trace ID without retaining raw secrets unnecessarily. Monitor incidents tied to context, including unauthorized retrieval, prompt leakage, and sensitive data appearing where it does not belong. The main lesson is to optimize before you scale. Govern prompts so they are concise, reusable, testable, and tied to quality. Improve retrieval with better chunks, metadata, re-ranking, and evidence selection. Keep memory scoped, summarized, pruned, and protected. Next, we move into operational efficiency. Caching, batching, rate controls, and agent designs that avoid unnecessary work.